This lesson looks at the histogram as a way of representing data and also compares histograms with dot plots and box and whisker plots to determine which is the most appropriate way of representing some data. We'll start with this example where we have 50 babies. Their lengths are all measured to the nearest centimetre. So we have one baby which is 47 centimetres long, 3 which are 48 centimetres long, and so on. I'm going to represent this data using a dot frequency diagram. You can see that the horizontal scale is the length of the baby in centimetres, and each dot represents one baby. Now, the problem with this form of display is that a dot frequency plot is more suitable for discrete data. These dots, as they're placed, suggest that each baby is exactly 47 or exactly 48 centimetres long, when in reality this data has been rounded to the nearest centimetre. So this baby that's 47 centimetres long could be anything from 46.5 to 47.5 centimetres. Although if it was 47.5, it would be rounded up to the 48 category. A more appropriate form of display for continuous data is a frequency histogram. We'll see that a frequency histogram can also be used for discrete data, but it's mainly used for continuous data. Instead of individual scores, we have class intervals or class boundaries, and we're usually dealing with a constant bin width, although it is possible to have frequency histograms where the bin width varies. A couple of other features are that there are no gaps between the columns and that the vertical axis is used for frequency. So here's that same data for the lengths of babies represented in a frequency histogram this time. We have class intervals from 46.5, 47.5, etc. And the class boundaries are those 0.5 values, the first one being 46.5, then 47.5, 48.5, etc. And we have a constant bin width of 1 centimetre. Now, a histogram can show the frequencies, as we've just seen, or we could have a relative frequency histogram, relative to the total number of babies in this case. So 1 out of 50 is 0.02, so 3 babies is a relative frequency of 0.06, and so on. The only difference being that the vertical scale now shows the relative frequency instead of the frequency. Similarly, we can show the percentage frequencies. And again, the only difference is that the vertical scale shows percentages. We can see that 28% of babies had a length of 51 centimetres to the nearest centimetre. A frequency polygon can be constructed from a frequency histogram by placing a cross in the centre at the top of each of the bars, including the centre of the space either side of the bars. These crosses are then joined up with straight lines. So just as a polygon in geometry consists of a shape with straight lines joined up, that's exactly the same with a frequency polygon. Now we can leave the two displays together, or we can erase the histogram to leave only the polygon displaying. The main advantage to this is that we can now show more than one frequency polygon on the same axes. For example, this could be the lengths of female babies, and we could draw a second frequency polygon to show the lengths of male babies, whereas with a histogram it's very difficult to draw more than one set of data on the same axes. Now, as I mentioned earlier, it is possible to represent discrete data with a frequency histogram. It would be important to give a context for the data so that we know whether it's discrete or continuous. However, in most cases, a dot frequency diagram is more appropriate for discrete data, whereas a histogram is more appropriate for continuous data. Now I'd like you to consider this example where we have 60 male birds and their beaks have been measured to the nearest centimetre. This data has been displayed in two different ways, a histogram and a box and whisker plot. Which do you think is the better form of display? Both have their advantages and their disadvantages, but I'd like you to pause the video and write down what you think. What would be the benefits of each form of display and what would be the disadvantages? Finally, I'm going to summarise the key aspects of describing and comparing data. There are three factors that you should mention when you're describing or comparing a set of data or two sets of data. Firstly, the location. Where is it? What we mean by this is measures of central tendency. So the mean and the median are the ones we normally use. If you have a histogram, then you have all the original data, so you can calculate the mean. And you can use a frequency method for calculating the mean. You can also work out the median from a histogram, but if you have a box plot, it's really easy to read off the median. Secondly, dispersion. How spread out is the data? Both the histogram and the box plot enable you to calculate the range. The box plot makes the interquartile range really easy to work out, and it can also be calculated with a bit more effort from the histogram. The standard deviation cannot be obtained from a box plot, but with a bit of work it can be calculated from a histogram. Thirdly, the shape of the distribution. What does it look like? We can describe the symmetry from either a histogram or a box plot. But we can also describe the modality, whether it has one mode or whether it has two modes and it's bimodal, or it might have no mode. We can also describe the grouping of the data and if there are any gaps. All of these from the histogram, but we cannot tell these from a box and whisker plot.